Hello friends, welcome to H2 Diamond Academy. In the last lecture, we have completed the discussion on the virtual work. So in this particular lecture, we will discuss about the problems on the virtual work. So let's start our discussion. So before moving further, let us recall what we have discussed in the previous set of lecture. Let us consider a string like this, okay, that is fixed at 2 points. Okay, let us consider this as A and this as B. Okay, and we have the tension in the string as T. Okay, so what will be the virtual work done? So we have the virtual work is equal to force times of virtual displacement. Okay, so this distance is AB, this distance is AB, so the virtual displacement is, and force is T, so T times of this is virtual displacement will be change in this distance AB, so this is change in AB. Okay, so this is the virtual work. Okay, so let us discuss these questions. So this we have discussed in detail in the last lecture. Okay, let us start discussing the problems. And the virtual work is the combination of, so virtual work is equal to force times of force into virtual displacement, and this displacement is not real, rather it is a imaginary value. We just imagine that there is some displacement, and that displacement is known as virtual displacement. So we have 5 weightlessness rods of equal length are joined together to form a rhombus ABCD with one diagonal BD. Okay, so let us draw the rhombus. Okay, and one diagonal BD. So let us name this as A, B, C and D, and one diagonal is BD. So we have the 5 weightlessness rod. Okay, 1, 2, 3, 4 and 5. Okay, if weight W is attached to C, if weight W is attached to C, weight W, okay, weight W is attached to C and the system is suspended from point A. So this is the fixed point. From this point the system is suspended. Okay, show that thrust in BD is equal to capital W upon 3. Okay, so let us analyze this. So we have 5 rods, okay, and these rods, okay, this one and this one will form a equilateral triangle. Okay, so this angle will be 60 degree, this is 60, this is 60, and this will be 60. Okay, so let us join this. Okay, so let us consider the length as, this is 2a, let us consider this length as 2a, and this is also 2a. Okay, BD is 2a. Okay, now because of this weight, this point B and D will try to move in inward direction. Okay, because of this weight will try to move in inward direction. Okay, so for restraining its movement in this particular direction, the thrust will act in this particular direction. Okay, because of this weight W, this point B and D will move in inward direction. Okay, so for balancing this, a thrust will act in opposite direction of this. So this is our thrust. Okay, so we have one force as W, that is weight, that is acting at point C, and we have thrust T in the thrust T in rod BD. Okay, so now let us write down the virtual work. Okay, let us write down the virtual work. So virtual work will be done, first one due to the tension and second one is due to the weight W. Okay, so we have the virtual work as is equal to tension times of change in this distance, change in BD. Okay, plus this weight capital W times of change in, this is point A and this is point C. Okay, so capital W into change in this distance AC. Okay, so we have BD as, let us take this angle as theta for the time being. Okay, after calculation we will put theta is equal to 30 degree. Okay, so this whole angle is 60, so half of the angle is 30 and half of the angle is 30. Okay, so for the time being we have considered this angle as theta. Okay, so we have the BD as, BD is equal to, so this is 2a, so this will be 2a sin theta, 2a sin theta. Similarly this is this distance. Okay, similarly this is 2a sin theta. Okay, so BD will be 4a sin theta. So this is tension times of change in, this is 4a sin theta plus capital W into change in AC. So AC will be, so this is 2a, so this distance will be 2a cos theta, 2a cos theta, and this is also 2a cos theta. The whole distance is 4a cos theta, 4a cos theta. Okay, so we have this as, let us take 4a outside, so we have t times of 4a into, okay, so differential change of sin theta is cos theta plus capital W times of 4a into change in, differential change in cos theta is minus sin theta. Okay, and this is equal to, from the principle of virtual work, this is equal to 0. Okay, so this 4a gets cancelled, so t is equal to, let us take this on the LHS side, so this is W sin theta upon cos theta, this is equal to W tan theta. Okay, and we have theta as 30 degree, this angle is 30 degree, so we have W tan 30 degree, so tension is equal to W times of tan 30 is 1 upon root 3, so this is W upon root 3. Okay, so we have thrust in BD, thrust in BD is equal to W upon root 3. Okay, so let us discuss question number 2. So we have 5 rods of equal length W form a rhombus ABCD with smooth hinges at the joints. The frame is suspended by a point A and a weight capital W is attached to C. A stiffening rod of negligible weight joins the midpoint of AB and AD, keeping these inclined at alpha to AC. Show that the thrust in this stiffening rod is given by this particular expression. Okay, so let us solve this. So we have rhombus ABCD. Let us draw a rhombus ABCD. Okay, this is A, B, this is C, and this is D. Okay, and there is a stiffening rod of negligible weight joins the midpoint of AB and AD. So midpoint of AB is this one, midpoint of AD is this one. Okay, so there is a stiffening rod like this, and we have AB and AD is inclined to AC at an angle of alpha. This is our AC line. So this angle is alpha and this angle is alpha. Okay, inclined and alpha to AC. Okay, show that thrust in the stiffening rod. Okay, so because there is a 4 rods of equal weight and a frame is suspended by the point A and a weight capital W is attached to C. So capital W is attached to C. Okay, so because of this weight capital W, this point, let us name this point as E and F. Okay, because of this weight capital W, this point E and F will try to move in inward direction. Okay, so thrust will act in opposite of this inward direction. Okay, so thrust will act in this particular direction. Okay, thrust. So now, and we have the 4 rods of equal weight and weight of rod is small w. So let us apply the weight small w. Okay, so the center of gravity of this, okay, so weight W will act at center of gravity of a particular rod. Okay, so for AB, the weight will act at this particular point. Okay, at the center of gravity of this rod AB. Okay, similarly, weight small w will act at point F. Okay, and we have, let us mark the midpoint of BC and CD. So this is the midpoint of BC. So weight W will act at this particular point. And we have the center of mass, sorry, the midpoint of CD is here. So the center of gravity will be here. So weight small w will act at this particular point. Okay. So the center of gravity of this whole system, okay, will act at here, small w. Okay. So we can replace this all small w with 4 times of w, 4 times of w at this particular point. Okay. So the combination of weights at point EF, G and H. Okay, so we have the weight at point E, F, G and H. So the combined weight 4W will act at the point O. Okay, so we can remove this one because we have taken the combined weight 4W at the point O. Okay, so we have the virtual work is being done by tension, combined weight 4W and capital W at point C. Okay, so let us write down the virtual work. Okay, so we have the virtual work as virtual work is equal to tension times of this whole distance is EF. So the virtual displacement will be change in EF plus this combined weight is 4W. So 4 times of small w into this distance AO. AO is, so we have considered the length of a particular rod as 2A. Okay. So this one be A and this is A. This is A and this is A. This whole length is 2A. This whole length is 2A. Okay. So this length will be, this is A and this is alpha. So this is A sin alpha. This is also A sin alpha. Okay. So the whole length is 2A sin alpha. Okay. Plus 4W into this is AO. So this will be 2A cos alpha. Okay. So this is 4W into change in AO. Okay. Plus capital W into change in AC. Okay. So we have the length AC as this is 2A. So this whole length is 2A cos alpha. So AC will be 4A cos alpha. So AC is equal to 4A cos alpha. Okay. And we have EF as EF is equal to 2A sin alpha. Okay. And we have AO. AO as 2A cos alpha. AO is equal to this distance is 2A cos alpha. Okay. Let us place the values here. So we have 0 is equal to T times of change in EF. This is change in 2A sin alpha plus 4W into change in AO is 2A cos alpha plus capital W into change in AC is 4A cos alpha. Okay, so we have this as 0 is equal to, this is T times of 2A into change in sin alpha is cos alpha. Okay, plus this is 8A small w into minus sin alpha. Change in cos alpha is minus sin alpha plus this is 4A capital W. Change in cos alpha is minus sin alpha. Okay, this is 0. So let us divide by 2A. So this gets cancelled. So 0 is equal to T times of cos alpha. And we have divided by 2A. So this is 4. So minus 4W sin alpha. Okay. And this is minus of 2 capital W sin alpha. Okay. So we have T is equal to 2W, 2 capital W plus 4 small w into sin alpha upon cos alpha. Okay. This is the expression. Let us further simplify this. So T is equal to 2 capital W plus 4 small w into tan alpha. Okay. So this is the expression for the thrust in the stiffening rod. Okay. So the thrust in stiffening rod is given by this particular expression. Okay. So we have discussed up to question number 2. So we will discuss further questions in next particular lecture. Thank you.